what's going on, everybody? So we are going into lesson 21, which is really just kind of a stretch on what we did yesterday. Sorry, I'm just trying to pull up my iPad. As long as you guys are feeling okay with the derivative stuff, today is pretty much just an extension of that. The first thing I want to do is, I thought I switched this last year, and I just noticed like 5 minutes ago it was still the same on this sheet. I'm going to cross off everything that's in this box, and I'm going to rewrite it a different way so it's easier to understand. So I'm going to get rid of everything that's in the box right there, and I'm going to write down this. And I'm kind of going right into it because it looks like there's only 2 people here right now. So I'm going to assume, with how nice it is outside, a lot of you guys are going to probably come back and watch this video at a later time. But the formula states if we have f of x times g of x, when we go to find the derivative of it, it's going to look like this. It's going to look like f prime of x times g of x plus my iPad just freeze as I'm doing it. Oh no, I didn't want to erase everything. Okay. Plus g prime of x times f of x. So I rewrote it to make more sense with what is written below. So it says that the first thing that we're doing is we're going to multiply the first derivative, which is this f prime of x. Oh, I can't highlight above it? Really? Well, that's dumb. But this part right here, I can box it in. So that's your first derivative. And then you're multiplying it by the second factor, which in this case is g of x. Then the second step is multiplying it by the second derivative. And I'm going to show this all out with an example number 1 as well, so it will make more sense for you guys. And then you're multiplying it by the first factor. So when I break it down and I show you guys how these work, it's going to make a lot more sense. And then we're going to add them together, because you may recall when we do, you guys may recall product rule. Anytime that you guys have the product of something, we always would add within that rule. Think of like exponents. If we had something like x squared times x to the third, if I were to ask you guys to multiply that, that is a product. You guys were always taught to take the exponents and just add them together. So product and that add are always kind of tied together. Okay. So I'm going to show you guys an example, a rundown of what we need to do, because this exercise says that we want to differentiate the product. So when we go to differentiate it, it's doing the derivative just like what we did for the last 2-3 days, however long we've been doing it, and it's just adding a little twist to it. So what I'm going to do is, off to the side, I'm going to rewrite this into 2 pieces, because that first part is being represented by that f of x, and the second part is being represented by the g of x. So I'm just going to write it off to the side. I'm going to say f of x is equal to x squared, and then I'm also going to write down g of x is equal to 3x plus 1. So if I were to ask you guys to find the derivative of this, because there's multiplication involved, because we're taking the x squared and multiplying it by the 3x plus 1, what we're going to do is find the derivative of each one of those separately. So on the left side, I'm going to find the derivative for f of x. So I'm going to do f prime of x. And it's the same rule that we've done. I'm not going to change anything. The rule was we take the exponent and we multiply it to the front. So I'm just taking that 2, I'm multiplying it to the front. Well, 2 times 1 is still 2x. And then we have to subtract the exponent by 1. So we're done with that side. On the next part, we're going to have g prime of x, because now we're doing the derivative for g of x. We're going to do the same thing. I'm just taking that exponent and multiplying it by the front, which in this case would be 3. And the x will end up disappearing because 1 minus 1 is 0. And that's it. G prime of x is just going to be 3. So now I wrote down the steps above, but I'm going to show you guys the method that I use. I call it the crisscross method, because what you'll notice that I said in the first step, we were multiplying the first derivative by the second factor. Well, if you look at what I have here, I have f of x and I have f prime of x. This is my first derivative. And it says you're multiplying it by the second factor. Well, what I wrote up here is f prime of x times g of x. So I call it the crisscross method because what I'm going to do now is I'm going to take this first derivative and I'm going to multiply it by the original g of x. So I'm just going to write out, I'll write it out in purple or pink or whatever color I chose, 2x times 3x plus 1. So that was the first step. Multiply the first derivative by the second factor. And this is why I wrote it the way I did up inside the box, so you guys can see how I'm breaking this down. The second step says that I'm going to take the second derivative, which is this g of x, or g prime of x, and I'm going to multiply it by the first factor. So now what I'm going to do is I'm going to write down 3, because that was the answer for g prime of x, and I'm multiplying it by x squared. And then the last step said that I'm just going to add the two solutions together. So all I'm doing is I'm taking the derivative of each, I'm going to almost kind of in a sense cross multiply, and then add the two solutions together. So the only thing here is I can simplify what I wrote down underneath. So I can distribute that 2x into the parentheses, and I'm going to get 6x squared plus 2x, and I still have the plus 3x squared. And now I could just combine like terms. So I'll have 6x squared plus 3x squared is 9x squared plus 2x. So if we were to find the derivative of x squared times 3x plus 1, it would come out to be 9x squared plus 2x. Okay? So I'm not going to do anything too crazy with you guys today. Next two are going to be exactly the same. Okay? It's just working with different numbers. So I did one where it was a monomial times a binomial. So it was a single term times two terms. The next one I'm going to do with you guys is two separate terms. So what I'm going to do is I'm going to rewrite both of these again to make life a little bit easier for us. So I'm going to say f of x is equal to 2x plus 1. And I'm going to say g of x is equal to 3x minus 2. Now that I have both of those down, I'm just going to find the derivative of each. So the derivative of f of x is actually just going to be 2. Because the exponent was 1, I could bring it out, nothing's going to change. If I do the derivative of g of x, so I have g prime of x, it looks like the answer is just going to be 3. Because again, the exponent was only 1, there's no exponent left over. Okay? Now that I have both of these, I have to follow those 3 rules that I wrote up top. Or if it's easier for you, you can use this like crisscross pattern or this cross multiplying that I mentioned in this last step. So we're taking the first derivative and we're multiplying it by the second factor. And my iPad only wants to freeze when I'm teaching Math 12. It's so annoying. And then I'm going to do the same thing on the other side. Now I'm going to take the second derivative and multiply it by the first factor. Well, now that I have that, I'm just going to write it out. So I have 2 times 3x minus 2. And then I also have 3 times 2x plus 1. And then I'm just going to take those two answers and add them together. So I'm just going to do that off to the side, simplify it down. I'm going to have 6x minus 4. And then if I distribute that 3, I'm going to have 6x plus 3. So now if I combine like terms, I'm going to have 12x minus 1. So the derivative for that 2x plus 1 times 3x minus 2 is really just going to come out to be 12x minus 1. If you're confused with anything I've done, don't be afraid to speak up. I'll help you guys out. I'll break it down for you. Exercise number 3, same type of problem, except this one's going to be a monomial times a 4-term polynomial. So this is what I'll end on, but it's going to be the same exact steps. There's just one little additional part to it, and I'll explain that in a second, because we didn't really go too crazy with those the other day. But the first part of this process is still going to be the same, because it says differentiate these. So I have f of x is equal to x to the 4th. I have g of x is equal to x cubed minus 2x squared plus 3x minus 1. And now I'm just looking to find the derivative of both. So if I go to find the derivative of the first one, a little bit easier because there's only one term there. In this case, if I multiply the 4 by the coefficient, I'll have 4x to the 3rd power. If I go to do the next one, just a few more steps because there's a few more terms that we have to find the derivative of. So we'll have 3x squared. If I bring the 2 out in the second part, I'm going to have 4x plus 3. And that minus 1 will disappear because we had an exponent of 0. So now that we have all of that, we can do our little crisscross now. First derivative multiplied by the second factor. Second derivative times it by the first factor. So I'm just going to write it out now. I got 4x cubed times x cubed minus 2x squared plus 3x minus 1. The second one, I'm going to put the x to the 4th out front. And then I'll have 3x squared minus 4x plus 3. And once again, because it was multiplication, this is product, so we have to make sure that we're adding the solutions together. And now I'm just going to simplify it. So I'm going to have 4x to the 6 minus 8x to the 5th plus 12x to the 4th minus 4x cubed plus 3x to the 6th minus 4x to the 5th plus 3x to the 4th. So this one, as you guys can see, it's a little bit longer because it was a 4-term polynomial. So I'm going to combine all my like terms. Let's see here. I got a 4x to the 6 and a 3x to the 6. I have a negative 8x to the 5th and a negative 4x to the 5th. 12x to the 4th and the 3x to the 4th. That looks like it's it. So I'm just going to rewrite them all. I have 4x and 3x. That would give us 7x to the 6. The negative 8 and the negative 4 would give us negative 12x to the 5th plus 15x to the 4th, and we're still left with that 4x to the 3rd. So everything we did was just like the first two questions. There's just one extra step in this one, and it says determine the slope at x equals 2. Now, we talked about this very, very briefly in lesson 20, right on the first page. Derivative is just a fancy way of saying we're finding the slope. So this whole thing down here, this is the derivative. It's also saying it's the slope of the original function. So this already is the slope. And because it's the slope, come on, write. My iPad's not writing again? It's moving. Did my pen die? Oh, I'm on an eraser. How did I get on an eraser? So this is the slope. There we go. So because that's the slope, and it says determine the slope at x equals 2, all it's asking you to do is plug 2 in for those x's. So anytime you find the derivative, that is the slope. It's just a fancy way of saying it. I'm not going to type it all in now. I know you guys can do that. Okay, so I stuck with the easier ones today. Tomorrow we'll go into those negative exponents. And then I just did a longer one that has 3 pieces. So tomorrow we'll just do those 2. And then next week we'll go into something called the quotient rule, which the quotient rule is very similar to what we did today, but it's with division. Okay, so if you guys got any questions, hit me up. Go enjoy the rest of this nice day because they're saying that it's supposed to rain for the next 2 days. Fun, fun, fun. But yeah, that's it. I'll see you guys tomorrow. Have a good one.